How's it going, guys? Today I want to go over a problem from Amazon, and today our question is called Symmetric Tree. Okay guys, so today our question is from Amazon. Our problem is called Symmetric Tree. Our problem description says, given a binary tree, check whether it is a mirror of itself, i.e. Symmetric around its center. So for example, in this binary tree, 1, 2, 2, 3, 4, 4, 3, this is symmetric, right? And we can kind of look here. And so the reason is, if we take this kind of right half and we reflect it around the center, it looks exactly like the left half, and vice versa, right? If we take the left half, it's the same thing as the right half. So if we were to just kind of take this tree and fold it onto itself, right, like a piece of paper, almost folding a piece of paper down the middle, the tree looks exactly the same. And that's kind of how we can tell if it is or isn't symmetric. So in this following example, 1, 2, 2, null, 3, null, 3, it's not symmetric. And the reason here, right, if we folded this tree across the middle, it actually would not look the same. So either this 3 would have to be the left child of this 2 here, or this right child of this 2 would have to be the left child. So that's the reason why it's not symmetric. So now let's talk about how we can actually go about coding this solution, right? So typically with tree problems, we're going to write recursive solutions. This problem says note bonus points if you could do it recursively and iteratively, but today we're actually just going to do it recursively. So with our recursive solutions, with tree problems, I always like to have some sort of shell function that just generally checks for a null case, and then otherwise we're just going to call and return the result of some like magical recursive function that we write. So that's the first thing that I want to do here. So like we said, we're just going to have a case to check for null, and then otherwise we're going to write some recursive function and return the result of that recursive function. So we're going to say if our root is null, what do we want to return? Well, if we don't actually have a tree, if we folded it against itself, technically it would really be symmetric. So we would just return true. I think a lot of times too in interviews, these kinds of base cases are good things to clarify with your interviews, but here we're just going to say it's true because a null tree reflected upon itself is null, so we're going to say true. Otherwise, we said we just want to return the result of a recursive function that we're going to write, so we're going to say return is symmetric, right, because that's really what this is trying to do, symmetric. And what we really want to check now is not the root anymore, right? Because the root doesn't matter. It's going to share the center of the subtrees. Now we really care about that folding, right, of the two subtrees. So we need to compare the left subtree and make sure that it's symmetric to the right subtree of the root. So we're going to pass the left subtree and the right subtree. So we're going to say root.left, and we're going to say, not rot, root, and we're going to say root.right. And so we're just going to return the result of whatever this recursive function does. So let's just write the function declaration. So we're going to say public boolean is symmetric. And we said we're going to take a tree node called left and a tree node called right. And again, those are just the left subtree and the right subtree, or I guess for you guys, the left subtree and the right subtree of our current root node. So now that we've actually reached this case or this function, we know, okay, we definitely have a root. Now we need to compare the two subtrees and make sure that they're actually symmetric. So the first easy check that we can actually do is we could just check if either the left subtree or the right subtree is null. Well, we just need to make sure that they are both null, right? So if either left or right is null, we need to check that they're the same. So we could just say if left is null or right is null, let's just return if left is equal to the right. Right, so if either of them is null, we need them to both be null so that they are actually symmetrical. Otherwise, if we're not in this case, we definitely have a left and right subtree. And so what we want to first do is just do a simple check to see if their values are the same, right? If their values aren't the same, there's no point in doing anything else because we know that there's no way it could possibly be symmetric if they have different values. So we're just going to say if left.val is not equal to right.val, well, then we're just going to return false, right? Because there's no way it could be symmetric. They don't have matching values. So now we've checked our sort of base cases, right? That's going to tell us if the tree is symmetric or not. And if we haven't hit those base cases, what do we always need in our recursive functions? We need our recursive calls, right, to continue our recursion. So what do we need to do? Now we need to check the subtrees of the trees that we're currently on, right? Or the roots that we're currently on. So what we really need to do is we need to check the left subtree's left subtree, right? And now we need to compare that to the right subtree's right subtree, right? Because if we folded them, those would be the trees or the subtrees that would match. So that's our first check. So we're going to say return is symmetric. We said left dot left, comparing it to right dot right. And what's the other thing we need to check? We need to check that the left subtree's right child is the same as the right subtree's left child, right? So those inner subtrees and those outer subtrees need to match. So we're going to say is symmetric of left compared to the left subtree's the left subtree's right child compared with the right subtree's left child. It's a little confusing, but hopefully if it doesn't make sense, kind of look back at the examples and you can wrestle through it. But that's really it, guys. And so I think the runtime here would really just be O of n, right? Because we're just checking and verifying, okay, every single subtree in this tree, which is touching all the nodes in the tree, is symmetrical. So I think the runtime would be O of n. Let's make sure that our solution works. Awesome, and it does. So guys, that's how to solve symmetric tree in Java. This is a LeetCode question that's currently being asked by Amazon right now. If you guys enjoyed this video and found it helpful, do me a favor, leave it a like and subscribe to the channel for more, and I'll see you guys next time.
Wish that sunny days wouldn't be special if it wasn't for rain. Joy wouldn't feel so good if it wasn't for pain. Death gotta be easy, cause life is hard. It'll leave you physically, mentally, and emotionally scarred. This is for my niggas on the block, twisting trees and cigars. For the niggas on lock, doing life behind bars. I don't say only God can judge me, cause I see